Now let's work on this USB area. Okay, so when you are making changes, you want to make sure that both the schematic and layout are both turned on. Okay, don't close any of the windows, otherwise it's going to cause some of the consistency issues. So for now, this area is done, but we want to look at this part. Okay, so USB has the JP1 next to it, right? So USB JP1 on the top, so we can keep it here, right? And then you got R1, R2, R3, R1. Okay, try to avoid these tangle wires as much as possible. It's too close to it, so let's move it a little bit to the right. R1, R2, R3, and you have C2, C3. Let's just put it here. Let's do this. C2, C3. This is better probably. C2, C3, and you have C7 here. And you have the fuse, which is F1. Let's see where F1 is. I'm not seeing F1 now, but we'll spot that later. And you have C1. C1 is here, not too far away from it. And you have the regulator, which is MCP something. It's this guy. Okay. Let's keep it here for now. And you have your C4. Okay, rotate it a little bit. Okay, so this is this region, C7 as well. I'm not seeing C7. Let's see. C7. Right, it's probably right placed here. Oh, this is C7. So we are done with this area pretty much. So I think we can directly just drag it to somewhere else. So R6 and LED1, these are power indicators. So they should be placed close to the power, because that's where that comes from. And we could either, I mean, place it here is fine. I mean, we have space here, so I think it's okay. It's okay. Right. Okay, so this area is done. We just place it here. I don't want to take the time to manually route it. Although I did it, I manually routed this area. Highly recommend it, but if you don't have time, I think that's alright, because the density of the traces is not too bad at all. So you can even like move these parts a little bit to the right, a little bit more, to give it more space to route the traces. Okay, so this, you can guarantee that it's going to work. All right. Now let's focus on the this one hasn't been placed in there yet, so this is critical. So I'm going to place this one. Let's see. All right, so I find out there's some space I can use, so I can do this, and then so I can place this guy over here, right? Okay, then we should focus on the low pass filter here. So the microphone first, but you can see this, the blaster is taking a space here. So what I'm gonna do is I will hide all the layers and only show the T-place, which is where the layers the blaster is at. So I'm able to select it and move it to empty area for now, so not affecting my organizing my layout here. So I'm moving this guy, which is the microphone, here. All right, and then you have R8 directly connect to it. So start from R8 is pulling up that pin. So just place it next to it. And you got R9, 10, 11. Okay, rotate it so it's able to make a direct connection. R10 and R11. You can see R11 and R9, they are connected to each other. See here, shorted on one terminal, so it's good to place them together. And this is, oh, is that a fuse? That's the fuse. So let's put it back to here, right? C9, R10, C9. Okay, this is making a really nice connection. R10, this guy. Okay, let's do this. And it's having a direct connection to the operational amplifier, so I just place it like this. So you can see at least these are very straightforward connections to make the routing easier. And you need a R12 here. Okay, so direct connection, so we don't want to change too much of it, just directly place them next to each other. And I think that's everything here. And then the this area, okay, this area. We got the BJT. So it's gonna be smart to move this down a little bit, so we got the space to place that IR module. Okay, so we can place the IR module over here, just for planning. Okay, and you can see that we still have space, so we can move this to the left a little bit. So the IR module can take this area, right? So first, this is the jumper you want to use. This is IR receiver. Place it here. Makes a lot of sense. And this is the resistor is R5. I believe it's a resistor connecting to the base of this guy. You can see, place it over here, so it's able to make a connection directly. And you got an LED, which is the power indicator, not that important. Place it here. It's making an easy connection here and here. Okay, and then you got R7. R7 is doing this, and you got D2, which is the IR LED. Keep in mind, see the cathode is over here, is pointing down. So you want to make sure that the orientation of that LED is correct, because it's going to emit IR light that way, because that's the receiver, instead of emitting to the left, right? So I looked into my layout. I think I intentionally did that when I was doing my layout. So I believe this is the correct direction. Let's just keep it that way, right? And this is C6. C6 is, I think that's power, and C5. So these are power low pass filters. It really doesn't matter where you place them, because eventually they are directly connecting to the top port copper VCC and bottom port copper ground. So they can be at anywhere, because it's really easy for them to drill a hole and connect to the either bottom or top. So we don't really care about that. We can just place them. Let me see. So if I do it, so just keep this a little bit away from this guy. Okay, don't want to put it too close. And then I'm gonna place two parts in the middle. It doesn't seem to be too empty. And then I got space for blaster, right? So this is a pull-up resistor. Let's keep it here. So I got a lot of space for blaster. I could either, let me see what I want to do. Because we can save a lot of space. For example, we define the dimension to be here. Then we can move this here and this here. We cannot shrink this area too much. You can also place this one here. The microphone module, I mean, it's a little bit unnecessary. So I'm trying to increase the chance of a successful layout. So I will just do. Let me see. See if that's doable. All right. Hope this is not causing too much issues over here. All right, and this one is a connector for JP3. Let's see what JP3 is. I'm not seeing it. JP3. Oh, is that a ground pin? It's probably a ground hole somewhere. Oh, this guy. Okay, it doesn't matter. So we can just place it at the edge. Just place it here. It's an empty area. Okay, and now we can find a space for the blaster. It's definitely taking too much space. And let's do this. All right, so we can move this down a little bit, not too much. Okay. Make sure they are at the same X. Okay, so look at the properties. You see X, no, the same Y. I'm sorry. So 193, 3728. Make sure this is at 3728 as well. 728. Okay, and then you can move this down a little bit. Oh, should do this first anyway. And then right click, redefine this, make it at the same level. And this one, so check the X over here first. See if we want to move this up a little bit. I think we can. 319. Let's do this first. All right. Move this here. So this can go here. Let's make sure this go up a little bit as well. This is 319. Okay. So see that we still have a lot of space. So why not just moving them to the right a little bit to make the routing easier? Okay, let's do this. And here can move these parts here. And so these can go to the middle a little bit. This one. Just give more space. Okay. So the density is still low, but I think it's okay. We just want to make it successful. Don't want to try too many times of auto routing. So let's try it really quick and see if that works. Okay. So I'm going to go to Tools. So when you do the auto routing, definitely you need to set the net class I don't think I am making wider traces, but it was 6 mils by default. I'm changing the width to 12 mil for all of them because the wider traces will reduce the resistance of the traces. And I used to do a definition of the power lines and making them wider, but I don't think we need to do that here because the poor copper will give you a pretty solid VCC and ground. And if you go to DRC, go to clearance, you want to make sure that vias are pretty far away from the all the any pads in there. But I think 40 probably is too much overkill. Let's do 20. Usually it was 6 for everything, right? But it's too close. It's very easily when you do the soldering, you can bridge the gap between the via and any other metal easily. Usually I use 40, but let's try 40 first, okay? Let's try 40 first. If 40 fails, we will just use a smaller one, okay, to make the routing easier. Let's just run it, okay? Okay, that's a very easy routing. So you can see that if you do the manual layout here, it's probably will be successful at the first time for the routing. It's 100%. Then end the job, and I think this is done. This is done. I can do a DRC check, just pay attention, see if it's matching the schematic, and see no errors here at the bottom. And if I go back to here to the schematic, and I can do a ERC check, it has a lot of warnings, but these errors are not really. You can ignore them. They are not really errors. See, so see it's making a connection, so it's okay. So we got a VCC power supply. Yeah, it's gonna work. Okay. All right, the very last step, which is doing the polygon. I think I should still show you how to do it really quick, even though it's really easy to do. Okay, just draw a polygon. Oh, I should place it back to the origin as well. I'll do that in a bit. Okay. For copper, so you can have a lot of metal areas for the metal for the VCC and ground. Okay, VCC and then go to bottom. Do another polygon. Ideally, your polygon shouldn't have any empty areas in the middle, but I don't think I have time to do it for the scope of this class. Let's just, oh, it's not joining, okay, see? So you wanna do this, join it, and connect the bottom port copper to ground, and then do a rest nest, okay? So you can see, luckily, you don't have too much empty areas, so that means most of the areas are covered by port copper, which is able to give you a pretty solid ground and VCC. So it's not really, routing a very thin trace through a long distance, so it's dropping the voltage, which is causing issues. And don't forget to run a final DRC, see it's no errors, and then you're pretty much ready. So what you want to do is go here, just use the default CAN processor to generate the Gerber file. Let's just do it on the desktop, select the folder, successful. So the next step you want to do is come to here, open it up, go to the drill files, cut it, Control X, cut it, and place it in the Gerber files, and select all, right click, use a 7-zip, and do a add to archive, and name it as whatever your name is. Okay, for example, my PIC PCB. Okay, and submit this to Canvas so I can directly send it to GLC PCB for fabrication.